minus infinity to minus 2, and 3 to infinity, right?
Yes,
And
sir.
please notice, these are open brackets, right? Because at minus 2 it is 0. It is not positive or negative, right? So it is minus infinity to minus 2. Union 3 to infinity. Okay, ma? In
Okay,
this
sir.
in this interval, it is increasing. And when is it decreasing? Between minus 2 and 3. Okay?
Okay, sir.
Understood, no? So
Yes, sir.
this is Descartes' rule of science. Okay? Okay, how functions, how the signs behave, etc., etc. Okay, this
Okay, sir.
method. Okay, what we have done here, we have just factorized and looked at different factors when they are positive, when they are negative, and ultimately this is a product of these ones. Okay, same logic you can use when there are multiple factors also. So, for example, if you have x minus 2 into x plus 10 into x minus 7, then what will you do? Again, you put these in ascending order. Okay, minus 10 to 7, right now.
Yes, sir.
Then you will evaluate each one of this. So for example, x minus 2, it is positive here, here, negative here, here. Okay, x plus 10, this is positive here, 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 negative here. Agree, no?
Okay, sir.
Agreed, sir.
X minus 7, it is positive here and negative everywhere else. Okay, then three negatives, negative, this is positive, this is negative, this is positive. Understood?
Yes, sir.
Okay, same you will use, for example, x minus 3 by x plus 3 in this case also. Tell me, when is it positive? X minus 3 by x plus 3. This is ratio of two numbers. Okay, when x is 3, it is 0. When x is minus 3, it is infinity. Right?
Yes.
Now tell me, when is this positive? When is this negative? X minus 3 by x plus 3. Using the same logic.
So procedure is the same as like the before
Same
sums.
procedure. Doesn't
Okay,
matter.
sir.
It
Once
doesn't
again.
matter. Same procedure. Because
Yes,
earlier
sir.
we did the product of two numbers. Now we are using division, right? It doesn't matter, no? Negative by negative is
No.
positive, positive by
Yes,
negative,
sir.
negative, like this.
Just a second, sir. I'll do it.
Ah. Shreyas, understood, no?
Yes, sir. I understood.
Ah.
Sir, it's increasing from minus infinity, comma minus 3 union 3 to infinite.
3 to infinity. Okay, very good. Shreyas, you
And
also
then
got the same thing?
decreasing from minus 3, comma 3.
Decreasing between minus 3 and 3. Shreyas, have you got the same thing?
Yes, sir. I think so. Yeah.
Got it, no? Okay, cool. So this is how when we have when you have ratio of different polynomials, or when you have ratio of or product of factors, or ratio of different expressions. Okay, you will be able to
Sure.
do this. Okay,
Sir,
now see
so
this.
before starting JEE, you will be doing each and every exercise, yeah?
What, no?
Like few sums. So like
What?
before starting the teaching of JEE syllabus, you will do few questions from each and every exercise, yeah?
No, no, this because you did not do, I am doing this. Otherwise you would
Okay, sir.
have got it.
Yes, sir.
Because you did not do, because if you had done this, then the other parts will become easy. Right. What do you want? You want me?
Okay, so
You want? So what is your preference? Tell me. You want me to
no,
do
sir.
this?
I'm just generally asking. I was generally asking.
Oh, okay, okay. See, the goal is you have to finish the basic level ones first. Okay. Whether you
Okay,
do
sir.
it outside or you do it here, but that has to be finished. Once that is finished, then going to JEE sums will be easy. Otherwise, those will look big. Okay.
Okay, sir.
Okay. This one 6A. Tell me, when is it increasing? When is it decreasing?
Once again. Sir, for here we can't do factorization.
No. You see,
Yes, sir.
for
That's what
a
even I'm
function.
confused, sir. It's not working out for me.
Wait. This is strictly increasing or decreasing. We should not factorize this function.
Oh,
You should look at the derivative of this function, and then if
oh
needed, you have
yeah,
to
I
factorize
forgot
that.
to derivate it.
Okay, so it is not about this function.
Okay,
Oh
sir.
no.
I
Okay,
Never
forgot to
mind.
derivate.
yeah, that's why I was telling you to practice these basic questions first. Understood?
Sorry,
No,
sir.
understood the importance of this.
Yes, sir. Sir, I'm again so sorry, sir.
No problem. First time, no. Next time,
Yes.
please ensure that everything is done. Okay.
Sure, sir.
So in our school, they will do each and every question of the book. How does it happen in school?
Sir, not every question. Like, suppose if there is a question which is repeating,
Mm-hmm.
so, which has the same type of steps and all, they tell us to do it as homework, or like
Okay.
they skip that question.
Okay,
And then
okay.
other than that, if it's like very less time for the exams and we need to finish the portions, they just
Mm-hmm.
do the important questions. We just finish up
Oh,
the
okay.
important questions
But
and leave the
generally,
rest.
they try to cover all the different types of
Yeah.
questions, right?
Yes, sir. If different types of questions are there, we do all of them.
Okay. Very good, very good.
If the different types of only there's one more question with the same type, then like if there's less time, then we skip it.
Okay. Good. So at least they will finish this book at least in the book in the school, no?
Yeah.
Okay. Very good. And you are going to another tuition, no? What will happen there? Again, the same book or some other material?
Sir, NCRT itself.
Sir,
See, this book
NCRT
Already.
only.
itself. Yes,
This
sir.
book
Yeah.
only, no?
Yes, sir.
Okay. Cool. And there it's the same syllabus. Whatever is happening in school, same chapter, right?
Right.
Yes, sir.
Okay. Cool. Okay. So this one, tell me 2x plus 2, right? When is it greater than 0?
Sir, sir, after doing quadratic, I forgot how to do for linear.
No,
Sir, can you just
this
explain that
one
question again
2
one more
2x
time?
plus 2,
2x
right?
plus 2 equal to
When is it
yeah.
greater than 0? When 2x is greater than minus 2, right?
Oh,
When
yes,
x
sir.
greater than
Linear
minus 1.
inequality.
That's it.
Oh, okay.
Okay.
Just using linear inequalities.
Linear inequalities.
Very basic one. Okay.
Okay, sir. So it's when x is greater than minus 1, it's increasing.
It is increasing. That's it. Okay.
Okay, sir.
Okay. So similarly, B, C, D also. Okay.
Okay,
Okay,
sir.
sir.
You know how to differentiate this, no? This will become little
Yes.
lengthy, but you will be able to do. Okay. Now do seventh one.
Sir, do we have to differentiate it until we get like quadratic equation because it's in
No, you
cube
will
here?
differentiate once. That's it.
Okay.
Only
So,
once different. You should only verify for f dash.
so now the seventh one.
Okay. Seventh one. Sixth E you try. Okay.
So right now,
No. You try later.
okay, sir.
You try later, and you'll find something interesting. That you will tell me in the next class. Okay.
Okay, sir.
Sure, sir.
Okay. Seventh one. In school, you have daily 1 hour maths class or more or less.
40 minutes, sir.
Daily 40 minutes only.
Sir, if you
Yes,
have
sir.
double period, it becomes 1 or 20 minutes.
1 or 20 minutes, sir. Only if
O-
there's double period. But
Okay.
that
But
won't be on every day.
regularly it is 40 minutes only.
So like
40
3
minutes.
days, 3 days it's 1 or 20 minutes, and then 2 days it's 40 minutes.
Oh, okay. Got it. So roughly on an average 1 hour.
Yes.
No, yes, sir. But the classes can be either back to back or like, there are other subjects and then again another maths
Oh,
period.
okay. But same chapter will continue, no? It will not be two
Yes, sir.
chapter.
So we are right now in school, we are in parametrics.
Which
We,
parameter? Oh, okay. Parametric differentiation, right?
yeah, yes, sir.
And
We just started it.
Tuition, it is again 1 hour or
1 hour only, sir, for 3 days.
1 hour only. Okay. There again, it's about practice or the lecture happens again.
Sir, can you repeat?
It's again like a lecture or it's more like study or and the practice you have to do in
No,
tuition.
sir, it's like a lecture itself, you can say.
Okay, okay, cool, cool. So your practice mostly will happen at home only then.
Oh, yes, sir.
Yes, sir.
Okay, cool, cool. Seventh one, what you have to show, you have to differentiate and show that this is always positive, the derivative of this function, right?
Yes, sir.
Are you getting this to be positive? When x greater than minus 1. This is what he is saying. What is the derivative of this one?
Sir, 1 by 1 plus
1
x
plus
minus 2
minus
plus x into 2 minus 2x by 2 plus x the whole square.
what 2 plus x
2
into 2,
minus
okay,
2x
minus 2x
2x by 2 plus x the whole square.
minus 2x by 2 plus x whole square.
Whole
Okay.
square.
Be careful about this minus. This minus is like this, or there's a bracket here. Is it like this, or is it like this?
So it's the whole thing.
It's like this, no?
Yes.
No, 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 no. If it is like this, then it should be this one.
Sir, it won't.
Agree?
Sir, but then only if we open the bracket it becomes plus, yeah. Like,
It becomes minus and minus here, right?
yeah.
This is what you are saying, no?
Yes, sir. No, sir,
Ah,
like, 2 plus x into 2, it will be minus 2x only. Like, after we open only, the minus will change to plus, yeah.
okay. V du, right? 2 plus x into derivative of this, right?
Yeah.
So we are differentiating this part, no? 2 plus x into this 2. Okay, minus dv. Right, right, right. Minus 2x,
Sir,
right?
minus 2x, yeah.
Right.
And then 2 plus
So
x the
this
whole
is
square.
minus, then if you open this, it will
You can
become
take
plus,
minus
right?
common, yeah.
So what will this become? 1 by 1 minus
What?
x?
Minus 4 into 4 plus 2x minus
Okay,
2
okay.
by
So
2 plus
then,
x.
then you have to show that this entire thing is actually greater than this thing, right? When x is greater than minus 1, this entire thing is actually positive. Okay, what happens here? If you open this, this becomes 4 plus 2x minus 2x, right?
Yes, sir. 4 plus 2x minus 2.
So that will get cancelled. What will be left? You will be left with 4 here, right?
4. 4
Yeah.
by 2 plus x.
Okay, 1 by 1 minus x minus 4 by 2 plus x
Whole square.
whole square. This is what you are getting, right?
Right.
Okay, now can you simplify this and show that this is actually positive? So this becomes what? 2 plus x whole square minus 4 times of 1 minus x, right? By 1
Yes,
minus
sir.
x times 2 plus x whole square, right?
Yeah.
Okay, then simplify this. 4 plus x square plus 4x minus 4 plus 4x, right?
Yeah.
Yes,
Agreed?
sir.
Okay, this and this will go, right? X
Yes,
square
sir.
plus 8x by
By 1 minus x
1
into 2
minus
plus x the
x,
whole square.
x plus 2 whole square, right?
Yes, sir.
Yes, sir.
Okay. Now, uh, x into x plus 8, right? So what does that mean? X into x plus 8 by 1 minus x. Did you do anything correct? Or something else is missing? When x is, okay. When x is greater than minus 1, right? What is saying? When x is greater than minus 1, is it always positive?
Yes, that's what he's asking.
Okay. Just check when x is greater than minus 1, is it always positive?
One second, sir.
So So x into, basically what you have to check, x into x plus 8 by 1 minus x. This is what you have to check, right? Because this thing is anyway positive. Okay.
Okay,
So
sir.
what does that mean? You have to minus 8. What about this one? Okay, just check manually only, no? When x is positive, what will happen here? When x is positive, I think it is becoming negative, no? I think we have done somewhere wrong. Some negative sign we have missed somewhere. You understood, no? What I'm trying to say? You got it, ma'am? What I'm trying to say. So what we have to show? We have to show once you differentiate this entire thing, whatever you are getting, that should become positive. Okay, ma?
Okay, sir.
Okay, sir.
Okay, so that should become positive as long as x is greater than minus 1, right? Okay?
Okay, sir.
Okay, sir.
Okay, cool. Do the next one.
Sir, eighth one.
Eighth one. Again, you have to differentiate. You have to differentiate and show that it is increasing. It is the derivative is greater than 0 between 0 and pi by 2. If you differentiate this, what will happen? Tell me. 2 plus cos theta into 4
Into
cos theta,
4 cos theta
4 cos theta minus 4 sin theta into
minus sin theta.
minus sin theta. Shreyas agree, ma?
Agreed, sir.
By 2 plus cos theta whole square, right now? Minus
Yes,
1,
sir.
right? If you simplify this, what will happen? The numerator. What you are getting? 8 cos theta, right?
Yeah.
8 cos theta plus 4 cos square theta, right?
Yes,
Plus
sir.
4 sin
Plus
square
4
theta.
sin square theta.
So we can write this as 4, right?
Yeah.
By 2 plus
Cos square theta.
cos theta whole square minus 1, right?
Yeah.
Okay. Now, what exactly is saying? Now you have to prove what you have to prove. You have to prove it is increasing. Where is this one, right?
Yeah.
You have to prove. You have to prove this is positive in 0 and pi by 2, right?
Yes.
Okay. How do you prove this?
So just replace the values theta with 0 and pi by 2.
Okay. At 0, what is it? 8 plus 4 by 2. 2 square, right? That works. At pi by 2, what? How much is this?
So it's 0
0 and 4 by
plus 4.
4. So that until
4
pi
by
by 2,
4
it's 4 by
minus
5.
1.
At pi by 2, it is actually 0, and before pi by 2, it's actually greater than 0. Understood, no?
Yes, sir.
Understood, sir.
Before pi by 2, it is actually positive. Or otherwise, what you can do, 8 cos theta plus 4 minus this thing. Okay. And if you
Sir,
expand
if
this,
it's 0, is it considered?
no, this is
Is it considered as increasing function?
no. At 0, you cannot.
So then
Okay.
after pi by 2, it should be in closed bracket, open bracket here. Why is it in
Ideally,
closed?
yes. What you are saying is an increasing function at 0 to pi by 2. Ideally, this should have been closed brackets actually,
Yes, sir.
because it has to be increasing. Okay. Then
Okay.
derivative has to be positive. Okay. So at cos pi by 2, the function is defined also. Okay. At pi by 2, how much is it is becoming? 4 by 2 square, right? 4 by 4, which is 1. 1 minus 1, 0, right?
Yes, sir.
Yeah. Ideally, it should have been the this one. Close brackets. Okay. Okay. 10th one log x. What is the derivative of log x?
Uh, 1 by x.
1 by x. 1 by x is greater than 0, right? When x is greater than when x lies between 0 to infinity. Right, Nama?
Yes, sir.
That's what you are saying. Okay. This one. It's neither increasing nor decreasing. How will you tell?
Sir, it should be 0.
No, no, no. Neither increasing nor decreasing means it could be positive sometimes, it could be negative sometimes, not necessarily zero. See,
Oh.
neither increasing nor decreasing means it could be like this, or it could be like this also, no?
Yeah.
And zero means this case. This one is neither increasing nor decreasing. That means it is doing both. Right? Increasing means continuously increasing. Decreasing means continuously decreasing. Okay, ma?
But then it's both.
No, no, no. So when we say strictly increasing, neither strictly increasing, neither increasing nor decreasing, what does that mean? It is both increasing and decreasing. Understood?
Yes, sir.
Okay. So for example, if you do the derivative, what does that mean? 2x minus 1. At x equals to half. Okay. When x is greater than half, it is increasing, right? When x is less than half, it is decreasing. This means, right? No?
Yes, sir.
Okay. So if this is minus 1 and this is 1, till x equals to half, it is increasing until x greater than half, right?
Yes.
And before that,
Before that, it's decreasing.
it is decreasing. It is something like this. Okay. It is
Okay, sir.
decreasing till x equals to half, increasing after x equals to half. Okay, ma?
Excellent.
Okay,
Yeah.
sir.
Good. Next one, 12th one. Your book has the answers also, no?
Yeah, it has.
Okay.
But
So
then we
12th,
didn't get the textbook set.
oh, you don't have the textbook set.
Yes, sir.
No,
We
sir,
have
they're
to
gonna
use the
give us the
soft.
free later on.
We have to use the soft copy which our teacher has uploaded.
Oh, acha, like that.
Yes, sir.
Yes,
So
sir.
they just ordered the books. They're like in our assembly hall. So
Oh,
then they
okay,
told
okay,
they'll
okay.
give
I
us
didn't know
in the
this. I thought
textbook.
you have the textbooks.
No, sir,
No,
they'll
sir.
give
We
us the
don't have
textbook.
it yet.
So far, we only
We'll
have the
get it
soft
soon,
copy.
though.
Okay, 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 okay. Got it, got it. Cool. Anyway, do this. Which of the ones these functions are increasing and decreasing?
12th one, right, sir?
12th, 12th. What you will do? You will do differentiation first. Okay. What is f dash
Okay.
For
x?
each one. Sir, minus sin x for the first one.
Okay, okay. Now minus sin x. Okay. Between 0 to pi by 2, what is this? Is it positive? Is it negative?
Sir,
Sir,
it's
it's
negative.
negative, so
It's
it will be
negative.
like
It's
Yes,
negative,
sir.
less
right?
than zero.
It's always negative. What does that mean? So first of all, you didn't put the brackets. I don't know. So many printing mistakes. You should put the brackets, no?
Sir,
Yeah.
the answer will be D, right?
No, no, no. See, the question is for cos x, is it increasing or decreasing? It is actually decreasing. Okay, 0 to pi by 2. Okay,
Okay, sir.
understood. What about cos 2x? What is the derivative? Minus 2 sine 2x. Right?
Yes, sir.
Okay, now be careful. Minus 2 sine 2x. Is it positive or negative between 0 and pi by 2? Or it can be both positive and both negative. That is the question here.
Okay, sir.
Okay, can it be positive? Can it be negative? That is the question.
Sir, can
Sir,
you
it's always 0, yeah?
No, no, no. Why
Sir,
is it always
because
0?
2 sine 2x. So minus 2 sine 0. Sine 0 is 0. Minus 2 into 0, 0.
Okay, no, put other
And
values.
then.
No, put pi by 6, put pi by 4, pi by 3.
Oh, yeah, okay.
So what does this mean? This means the value should lie between minus 2 sine 0 to minus 2 sine pi, right?
yeah.
Okay, now tell me what is this value? This is 0, right?
Yeah.
Okay,
Sir,
so
this also 181 also will be 0.
0, but in between minus 2 sine, this includes all values, no? This
Yes,
includes
sir.
minus 2 sine 0, minus 2 sine pi, minus 2 sine pi by
Sir,
4,
in
pi by
between it will
6.
be negative.
In between negative or positive, or in between
Sir,
it
it
will
will
be
Negative.
Can it be positive also in between? That is the question.
Sir, once again.
Just check. That is the important thing. Minus at the end points it is 0. That is fine. In between it is negative at least at some places, right? So for example at pi by t it is negative, right?
Sir, it can be positive as well.
When is it positive? If it is positive.
Sir, minus 2 sine 120. 2 into
Minus 2
60.
sine 120, how much is that?
Sir, it's 1 year.
Minus 2 sine 120. Sine 120 is still positive, no? Minus 2 sine 120 is still negative only, no?
Negative,
Oh.
yeah.
Oh yeah, yes,
Understood.
sir.
Okay, so is it positive at any point?
No, sir, it's not.
It is not positive. That means
Not
this function
positive at any
is
point, sir. Yeah.
this function is always decreasing. Okay, ma?
Decreasing.
Okay, sir.
Okay. And similar logic do for the third one. Cos
Sir,
3x.
so then the answer will be all of the above, right? A, B, C, and D. Both, all of these.
No. We checked for A and B only, no? We didn't check for C and D. So
Sir,
this
but C
function is
also will like
decreasing.
mostly decrease itself.
Wait,
No?
what is the question? Read the question carefully.
Which of the following functions are decreasing on 0, comma pi by 2?
So we checked for this one, this is decreasing, right?
Yes, sir.
We checked for this one, this is decreasing. We have to still check for cos 3x, no?
Oh, yes, sir.
You differentiate. Now what you will get? Minus 3 sine 3x. Okay?
Minus 3 sine 3x. Exactly.
Okay. Again minus 3 sine 0 to minus 3 sine till how much this time? 3x. That is 3 pi by 2. Understood?
Yes, sir.
Okay?
Yeah, 3 pi by 2.
Minus 3 sine pi. Now is this positive, negative? Can it be only positive, only negative, or both this time?
Oh, sir, it can be positive.
It can be positive this time, Kritik?
Yes, sir, it can
Or
be.
is it always negative?
It can be positive this time.
Sir, I only did for it can be positive. I didn't do
Yes,
for
sir, that's
negative.
all.
Are you feeling it can be positive? Minus 3 sine, some number between
Sir,
0 and pi
minus
by
3 sine 270 itself. It's minus
minus
3
3
into
sine
minus 1.
270, but this is open bracket. Tell me some other number, let's say 240. At 240, what is happening? At 240, is
Once
it
in,
positive?
sir, it will be positive, yeah?
Yes,
How
sir,
much
that's what
is
even I
how
got
much is sine
positive.
240?
Sir, I don't know, but then it will be minus 3 into a negative number only.
Ah,
Because
right.
it's
It is
coming in
positive.
third
Okay.
quadrant.
It is positive
240
only.
is
What you are
in
correct. You
240
are saying.
degrees in third quadrant, and then sine will be negative, yeah, in
Oh,
third.
yes.
Negative.
It is positive only. Okay. So what does that
Yeah,
mean? So this derivative is sometimes
it'll be
negative,
increasing.
sometimes positive. Right now.
Yeah.
Okay. So for example, at pi by 6 it is negative. At 240 it is positive. Right. So what does that mean? It is neither increasing nor
It's
decreasing.
increasing.
Okay. Okay. Now another important thing. Sine 240. How do we evaluate that? Okay.
So previous case, it's
Sir,
neither increasing nor decreasing, or
This is neither increasing nor decreasing. Because some places it is negative, some places it is positive, no derivative.
sir, isn't it like always positive?
It is not always positive, no. Minus 3 sine 3x. At x equals to 30 degrees, what is this? Minus 3 sine 90. Minus 3, right?
Oh yeah.
Okay. So that's why it
Okay.
is sometimes negative, sometimes positive. Okay, ma?
Okay, sir.
okay, sir.
Okay.
So it's neither decreasing nor
Neither
increasing.
decreasing nor increasing. Okay. Now, and one important thing. Sine 240. How will you evaluate this kind of things? Or sine 225? How do you evaluate this one? Tell me.
Sir, for sine 240, we can do sine 180 plus 60 and then
Ah,
take it as minus sine 60,
minus
which
60. What
is,
about this one? Sine 225. 180 plus 45. Okay.
yes, sir.
Sine 315. How do you do this?
Sir, is it 360 minus 45?
360 minus 40. What will that become?
Sir, sine 360 minus 45 will become sine 45 itself.
Sine
No,
45
minus sine, minus sine 45.
minus sine 45. Okay. For example, sine 150. How will you do?
Sir, sine 180 minus 30.
180 minus 30. Okay, very good.
Sir,
Shreyas,
sine
you are
30.
also clear now in this?
Oh, yes, sir.
Okay, very good. Now D, finally, tan x. Is it increasing? Is it decreasing?
Sir, it's increasing only.
Why?
Sir, because tan 0 to 90 all will be increasing.
Increasing.
Tan 0, 0 and then tan 30 is
Okay, okay. Tan x is always
1 by
increasing.
50.
Okay,
Yes.
what about tan
Increasing.
2x?
Sir, I have to check.
Tan 2x. Just try that. One second, man.
Yes, sir. Sir, it's neither positive nor negative.
Yes, ma'am. Tan
Sir, the
2x.
answer is neither positive nor negative.
Why?
Sir, because tan 120 is coming negative.
Tan 2x.
Yes, sir.
Tan 2x, what is coming negative?
Sir, tan 120.
And 120.
Tan 120 is coming negative. So what? What is the question? The
Sir,
function
Sir,
question
it'll
is
be
whether it is
increasing, yeah.
increasing or not.
sir, it's doing both increasing and
Wait,
decreasing.
wait, wait, wait.
Because
Don't
there
get
is
confused.
positive and
Wait, wait, wait.
negative. So it
For what you have to check whether it is positive or negative? Do you have to check for tan x?
Sir, tan 2x. You told
No, no.
tan
Do you have to
2x.
check for tan 2x or derivative of tan 2x?
Oh, yeah.
Okay, don't make this mistake. Okay, don't get confused. You have to check for derivative of tan 2x, not tan 2x. Okay,
Okay.
see what
never mind.
what see what you are saying is okay. What I am trying to say is tan x is always increasing. Okay,
Okay, sir.
okay. So sometimes it can be negative. That doesn't mean it is not increasing. No,
Yes, sir.
it is increasing. It could be negative, but still it is increasing. Okay,
Okay, sir.
okay. Tan 2x will look something like this. It
Sir,
could be
it's
negative
sec
at some
square x
places.
into 2, yeah?
2 into secant square x,
Sir,
right?
so it's obviously increasing only
It's
because.
obviously increasing because it's always positive, right? No,
Yes, sir.
so it could be negative, but still it is increasing. Okay, ma?
Okay, sir.
Okay, next 13.
Yes, sir. Sir, which is considered the hardest chapter in 12th math?
In maths, it is calculus only.
Hmm.
Calculus, more of integral calculus. The future, no, the ones that you are going to get, those will be the hardest.
Sir, will matrices chapter be good?
Matrices, huh?
Yeah.
That you have in second year or first year?
Sir, second year we didn't have it
That
in 11th.
Oh, okay, okay. That is easy only. Matrices. Are you facing any difficulty there?
Sir,
No,
we
sir,
didn't
we
have
didn't
any.
start yet. I'm just asking.
No, no, those are all easy only.
Oh,
Only integral calculus is actually a little tricky, but not at your board level. Your textbook has got easy ones only.
oh, then fine.
NCRT, you don't face any issues. Okay, NCRT, tell me what are the chapters in your first year? You have complex numbers,
Yes.
right?
Complex numbers, then
Quadratic.
quadratic,
Uh,
uh,
Sir,
then
sets, relations and
sets,
functions,
sets,
trigonometric
relations,
set,
functions,
sets relations,
limits and
trigonometry,
derivatives,
trigonometric functions, limits and derivatives,
limits,
probability,
limits,
probability,
derivatives, probability,
probability, statistics,
probability, statistics,
straight
and
sequence
lines.
and series, permutations,
sequence, sequence and series,
permutations,
permutations and combinations. That's it, no?
then
Straight lines.
introduction to 3D geometry.
3D geometry is also there.
Yes, sir.
Sir,
Ah,
even straight lines is also there.
straight lines I have written.
Oh,
Yeah.
This one, circles, parabola, that is also, conic sections.
yes, sir. Conic
Yeah,
sections
conic
also.
sections also.
Conics, okay. Okay. Oh, okay, tell me. If you have to rate this chapter, easy, difficult, hard, complex number, tell me.
So
Easy, sir.
that is easy.
Easy only. Quadratic,
Sir, that is
Easy.
also easy.
easy. Sets relations,
Easy,
Sir,
sir.
complex numbers and quadratic equations are in same chapter.
it is in the
They
same
both
chapter,
are
but
together.
in
Yes,
our
sir.
book it is in the same chapter, but this thing is ideally should be different. Okay. Sets
Okay, sir.
relations,
Sir, sets is easy, relations and is it's a little tough.
little tricky. Okay. What about trigonometry?
Relations and functions.
Sir,
Trigonometry
sets
is easy.
the word problems are there. Yeah, those are a little bit confusing.
What problems means these kind
I
of
mean,
problems?
yeah, when there are three circles, two circles are
Okay,
fine.
okay, okay, okay. Then we'll revisit them. Okay. Relations, relations
So
little
relations
tricky,
is
right?
tough, sir.
What is
It is tough.
equivalence relation? What is reflexive? What
So
is
we didn't learn
transitive?
all that.
Okay, okay. Well, relations is easy only.
So
Okay.
relation finding the domain and range few questions are difficult. Like
We'll
especially the
we'll
Yes,
do that.
sir.
modulus
Like,
and all.
sir, with the graph also, that is also a little tough, sir. Instead of modulus is
Oh,
fine,
okay.
but
Wait,
like,
wait, wait. Where are your functions? You don't have any specific functions chapter?
so relations and functions are together
Oh,
only,
okay,
sir.
okay. Relations and functions. Okay, got it.
So
This
we
So
have
people.
yes, sir.
modulus
Finding the
function,
function is
signum
tough, sir.
function,
Okay,
step.
okay. Because ideally this functions is there, no? This is the first part of calculus. Okay.
Oh yes, sir. That's why most of
That's
the
why people find it little tricky. The beginning of calculus, if you see that the book I sent you, calculus, Thomas calculus.
yes, sir.
The first chapter is functions, no?
Yeah. So limits, I mean trigonometry is again easy itself.
Trigonometry is easy.
Yes, sir. Because most of the questions we got, I think CBSE based, it was all like applying the formulas itself,
Formulas,
like
okay.
the coding
Limits,
questions.
limits you will
The
find first.
limits was a little tough, but derivatives was easy, sir.
Derivatives is easy. Limits you will find tricky. Okay.
Yes, sir.
In JEE also limits are difficult. Derivatives are easy.
Yes, sir.
Continuity differentiability, those you will find little tricky. Okay. What about probability?
So probability was easy.
Statistics,
Statistics also was easy,
So
sir.
statistics also is easy.
sequence and series.
Sir, a little tough, sir. I felt sequence and series was a little
Sequence
tough.
and series little tricky. Yeah. Okay. Good.
So sequence and series proving ones are tough. Like the normal questions are easy.
Oh, okay. Okay. Got it. Got it.
So we didn't
Uh,
have to study the proving ones
which
last year.
which one, ma?
Yes, sir.
The proving questions from sequence and series.
Oh, okay. Okay. Got it. Got it. And what about straight lines?
So straight line's tough, sir. For me, I
Straight.
felt from the beginning it was tough only for me.
Oh, is it? Straight lines. Ideally, it should have been very easy. Straight lines. Then conics would have been tough for you then.
So
No,
straight lines for
conics is easy,
me,
sir.
straight lines the last exercise is tough.
Okay.
Like
Okay.
the
What?
distance formula, those sums are
Yes, sir.
very
The
tough.
foot of the perpendicular, all that.
Oh, acha. Okay. Okay. I think somewhere you
Then
missed them, but those are
image,
all straight lines is pretty easy. And then what about conic, circle, parabola, ellipse, hyperbola?
So that was easy, sir, because half of them were straightforward with formulas itself, applying
Okay.
the.
Okay. And 3D.
So 3D also again easy only, sir.
3D is, you don't have vectors in first year?
No, sir.
Vectors is in second year. Okay. PMC?
The permutations and combinations was all right, sir. It's not that hard, not that easy.
Okay, this is actually moderate, right? This is moderate. Straight lines you have to do sequence and series functions. Okay. Then, okay, good. Okay. So then what we will do, we will always be little ahead than what you like. So for example, you are little ahead now here. We'll be little ahead than what is happening in school, so that we can concentrate on other things also. Okay.
Okay, sir.
Okay.
For example, next time when in school this is happening, this becomes pretty easy for you.
Yeah.
Okay. So this till this part it is fine. What becomes tricky is when it comes to integral calculus, no, that becomes little tricky. Okay, and at least CBSE level everything will be easy only. What we should be more worried about JEE syllabus, right?
Yes, sir.
Okay, so my only request to you guys is whatever homework that I am giving, no, if you feel that it is heavy, then tell me. Then I'll reduce it. Okay. But
Okay, sir.
once we have agreed that homework should be done. Okay.
Okay, sir.
Okay. Cool. This one, what we are doing? When is it decreasing? Right. What does that mean? If you differentiate this, what you'll get? 100 x
Sir,
power 99
99 plus cos x.
plus cos x. And
Okay, sir.
between 0 to 1, is it positive? Is it negative?
Sir, it's positive only.
0 to 1. First of all, how do you know?
Sir, when you substitute 0,
Ah,
the 100x raised to 99 becomes 0 and then cos
this
0
is
is
0
1.
and this is 1. Okay. Very good. Then
And then cos 1 will obviously be 1 only because between 0 to 90, everything is positive itself.
wait. Cos 1, is it positive or is it negative?
So it must be positive only.
Why is it positive?
Sir, because between 0 to 90, everything is positive.
Oh, okay. Wait, you have to
Actually, 0 to 180 actually.
no. Wait. So here, when he is saying 0 to 1, right? That is 180 degrees. Okay.
Oh,
This 1 means 180, this 1 radian. Okay. So when you are
oh,
not given degree, by default, it means it should be counted in radians. Okay.
okay, sir.
So what he means here is when he says 1, what he is meaning here is what is pi? Pi is 3.14, right?
Yes.
He is roughly saying it is around pi by 3. Okay, understood. Pi by 3 is 1.14, no?
Yeah.
Little less than pi by 3. He is saying when 0 to 1 means he is saying 0 to pi by 3. He is roughly saying
Oh,
this. Understood?
okay, sir.
So don't get confused. If you are given 4, then the answer would change. Okay.
So it will be
Then it is
3.14 by 4, yeah?
3.
Four.
No, if it is 4, what does that mean? See, 3.14 is pi.
Yeah.
4 is what? 4 pi by 3.14, right?
Yes, sir.
Understood.
Right.
It is greater than pi, right? Greater than pi. That is in third quadrant. Okay, ma? You have to be
Okay, sir.
when you are given plain numbers, no, don't get confused. Don't read them as degrees. Okay? Whenever
Okay,
you are
sir.
given plain numbers, you have to read them as radians, not degrees.
Okay, sir.
Okay, so because it is like 0 to pi by 3, then this is working. Okay? This is always positive. That means it is increasing or decreasing. It is increasing, right?
Yes, sir.
Okay. What about this one? Pi by 2 to pi.
Sir, it's decreasing
Why decreasing?
because you get negative answers.
Why you will get negative? Cos x will be negative. Okay.
Yeah.
But we have 100 into x power 99 also. This will be such a
Yes.
massive, huge number that this negative doesn't even matter, right?
Yeah. Oh, yeah.
Yes,
Agree,
sir.
no? This is such a big number, right?
Yes, sir.
This is at least minimum 100 into what is pi by 2? 1.6. 1.6 power 99. Right? At the minimum, right?
Sir, how do you get 1.6?
Pi by 2, no? What is pi? 3.14, right?
Oh, so in numbers case we take it as 3.14 and then for
Yes.
trigonometry we take it as
Yes.
180.
If it is numbers, you have to take it as 3.14. Okay?
Okay, sir.
Okay. That is the general pi, right?
Yes, sir.
If you have to do it in degrees, then you have to do this. Okay.
Okay, sir.
Okay. So, for example, in a calculator, right? If you take a scientific calculator and the input cost 3.14, then we will get a number close to 1. Okay. But if you put in that is when you put in the radian mode. Okay.
Okay, sir.
But if you put in a degree mode, then cos 3.14, you will get cos 3.14, you will get like 3.14 degrees. Okay, that will be a number close to 1. Understood?
Understood, sir.
Okay, so when it is not mentioned, pi means 3.14. Okay?
Okay, sir.
Okay, otherwise, if it is degrees, you'll put it as degrees. Okay? Okay,
Okay,
so
sir.
this number means this is a massive, huge number. Okay? Understood?
Yes, sir.
What about the third part? This is always positive. Okay. This is also always positive. Right now?
Yes, sir.
So it is never decreasing basically. Right?
Yes, sir.
Everywhere it is positive. Right now?
Yes, sir.
Okay. 14th. Do you have to go somewhere or we can continue?
So right now I'll be having other tuition.
Okay. Then we'll continue
We have
on.
CBSE.
Okay, you also have to go, no? Then we'll
Yes,
continue
sir.
on Saturday, no?
Okay, sir.
Yes,
Okay,
sir. Saturday.
Saturday, what you have to do? You have to finish this one, and then
Sir, the 4-5 questions there.
these 4 5 questions. But that's not. I'll give you another set of questions from Thomas Calculus. Okay.
Okay, sir.
Okay, sir.
Okay.
Sir, so
So
the whole 6.2 exercise.
this two anyway it is done. Okay. I'll give you
Okay.
another set of questions from Thomas Calculus. Okay.
Okay, sir.
Okay.
Those things I'll give some around 40 questions. Okay. You should be able to do.
Okay,
Like
sir.
in this class only we have done some 20 questions, no? So 2 days, 40
Yeah.
questions you will be able to do easily. Okay?
Okay, sir.
Okay, ma?
Okay, sir.
Cool then. Take care. Bye bye.
Bye,
Thank
sir.
you, sir. Bye, sir.